it was actually given by the wave theory and was published so closer to Newton's theory, and people neglected it, so it became the strong evidence that was actually the fault of Newton's theory, right? Okay, that's great. So this is about wave theory of light. Okay, this is about the wave theory of light. Now, this wave theory was little bit transformed by other scientists. Later it was found that light wave is not a longitudinal wave, it is actually a transverse wave. Right? It is actually a transverse wave. Yeah. And what was the achievements? It could explain everything. It could explain reflection, refraction, and these phenomena we will explain them in further lessons. I know until it's a transverse wave भनेर प्रुफ भयो के मतलब प्रुफ गरे उनीहरूले तर एउटा कुरा उनीहरूले एक्सप्लेन गर्न सकेनन् that was polarization of light could not be explained किनभने polarization of light is a property of electromagnetic waves. Property of electromagnetic waves. So polarization could not be explained with the help of Huygens principles, right? So let's move on to next theory, that was electromagnetic theory. Actually, James Clerk Maxwell, first of all, let me know, okay, that these electromagnetic waves actually, these electromagnetic waves, they are actually released by charged particles. When they are in acceleration, they will release electromagnetic waves or electromagnetic radiations, and this was first discovered by James Clerk Maxwell. Yeah, it was actually he gave the theory of electrodynamics, right? Charged particle, when it is in acceleration, will release energy in the form of electromagnetic waves, and he just gave the theory, and according to his theory he calculated the speed of light, and that was very, very close to speed of light that was determined experimentally by many scientists. That was close to 3.0 into 10 to the power 8 meters per second, right? That was very, very close to this value. So Maxwell said that this is not an accident. This is not an accident. Light is actually an electromagnetic wave. But what is electromagnetic wave? Does it travel in a medium? What does it do? How does it travel? And the answer is electromagnetic wave does not need medium to travel. In electromagnetic wave, there is a variation of electric field and magnetic field. Let me draw a figure. This is y-axis, this is x-axis, and this is z-axis. Suppose the electromagnetic wave is traveling in this direction. There will be a variation of electric field in this direction. There will be a variation of magnetic field in this direction. So in this way, you have an electromagnetic wave. The variation of electric field and magnetic field, they are perpendicular to each other and perpendicular to the direction of propagation of wave. So that's it. That's actually the case. Right? So that's all about the electromagnetic waves. So Maxwell discovered electromagnetic waves, and he calculated the speed of electromagnetic waves, and that was very close to the speed of light, and he proposed that light is an electromagnetic wave, and we know what is electromagnetic wave and how electromagnetic waves are produced. The main source, the fundamental source, they are charged particles. When they are in acceleration, the electromagnetic waves were detected. And it was first experimentally proved, Maxwell's theory was first experimentally proved by Hart. He actually experimentally produced and detected electromagnetic waves. So, and this electromagnetic waves, it could describe polarization, it could describe about polarization and all other properties like diffraction, interference, and everything. Now we know that light is an electromagnetic wave, but when we move on, we have a problem ahead. So let's discuss that. So there is an important effect known as photoelectric effect, and others are also observed that could not be explained with the help of this wave theory, right? For example, photoelectric effect, and another example, excitation of atoms, or atomic excitation, let's say atomic excitation, photoelectric effect. They could not be explained with the help of wave theory. Actually, they need the previous corpuscular theory, just like a corpuscular theory, and they could not explain. So Einstein, he actually proposed quantum theory. He proposed quantum theory of light. He proposed quantum theory of light, and what does that say? Light is composed of small bundles of energy, that is, small packets of energy, and we call the packets photons. We call the packets photons. The packets, we call them photons, right? We call the packets photons. And with the help of these photons, packets, and bundles of energy, we can explain the photoelectric effect and atomic excitation. Actually, we need particle theory when we are talking about the absorption of light, when you are talking about the emission of light. During these cases, we need to explain in terms of photons. So there is a huge debate about whether light is a particle or a wave. So now we have finally accepted that light has a dual nature.